This is mat 320. Mat 320. Okay, so it's under line integrals. So if you don't know the line integrals, these are some of the ideas that you need to know. Okay, so the first thing here will be to understand the formula for line integrals. So the formula looks like this. Let's say you've got this stuff here, of which they want you to integrate. So what you're going to do here is to use this formula, okay? So we've got x t y of t z over t. This is the formula you guys need to know. So next here will be the integral, okay, of x with respect to t squared, the integral of y respecting t there squared, plus the integral of z dt there squared and dt. Okay, so because we're integrating with respect to t, so this is the formula. You need to know this formula right here. So now let me try to answer this question using the formula and see what we're supposed to do. So I've been given this. So what we've been given here, we'll pretend it's what is right here. So what we need to do is to get these equations. They have given us the three equations here, okay? So the first equation right here will just work here. The second equation will work where y is, we'll put sine t, and also here. The next one here, we get t, put it where z is, and right here. So let me start. So we will say the integral, the limits are from 0 to 2 pi. So I'm starting from here. So the lower limit here is 0, upper limit is 2 pi. So there, now the expression we have here, right here. So what we do with it, we start replacing. So where y is, we put sine t, because y is equal to sine t. There we have sine z. Now we're not going to write sine z, we put sine t, which is this one. And thereafter, we now find the integrals. I mean the derivatives. So the derivative over x with respect to t here will be negative sine. So and sine t. So if you don't know how to find the derivatives, kindly watch my videos on how to find the derivative of sine, I mean cos t. So here it's just like this. It's like this one, okay? So it will be like this. Because we are respecting, sorry, actually it's t here. We are respecting t. So this is how it will look like. And we put it here. So the next thing will be to just find the derivative of this stuff, of which it will just be cos t. And the power 2 will be outside. So put it here. Next will be to find the derivative of this, which is just a 1. And then we say dt. So now from here we can clean up things. So right here we have sine squared or sine t squared. Sine t times sine t is sine t squared. Right here we have sine t squared plus cos t squared plus 1. Because this one, because of this power, this negative will disappear. So we have something like this. And here it will be dt. Thereafter, using the trig identities, this one is the same as the 1. So it will be 1 plus a 1. Okay? So this is 1 plus 1, which is just equal to a 2. 1 plus 1 is a 2. and this can come outside the integral sign, so it will look like this. This is how it will look like. You see the way it looks? So now this is the step where we are at. So we need to integrate this stuff. So let me show you on how to integrate. Once we just integrate this with respect to t, we are done. So how to integrate? So now how to integrate this one? Let me put it here. We have root of 2 integral from 0 to 2 pi sine t squared dt. So this is what we are integrating right here. So here we need to use the trig identities. Trig identity. So this will just be, if we use the trig identity, what is here will just be a 1 minus cos 2t over t. Then we say dt. Okay. So now here, since we're integrating this, we have a root of 2, and the 2, this is a constant, it will come out. So we'll remain with this right here. Okay. So now we can work it out. The integral of 1 is what? Is t. Minus the integral of this will just be cos. It will be cos. This is cos. Let me see. The integral, let u is equal to, it will just be a sine, sorry. Sine 2 there over 2 right here. And the limits are from 2 pi, from 0 to 2 pi. So now at this point, we have a 2 right there. And then here we have a 2 pi minus this. When we put this right here, it will just give us a 0. So it will just be a 0 there, minus 0 minus 0 when we put there. So we remain with root of 2 times 2 pi, of which this 2 and 2 will cancel. So our final answer will just be a root of 2 pi. This is our final answer.